Okie dokie. Let's walk through the bonding review for honors. Sharing electrons. We know that that is a covalent bond. Gaining electrons. That is a nonmetal. Unequal sharing of electrons. Polar covalent bond. C of electrons. Metallic bond. Mobile electrons. Metallic bond. Or I'd take metal, either one. Loses electrons, that's always our metal. Metals are losers. Becomes a cation, also the metal. Equal sharing of electrons, non-polar covalent bond. Very high melting points, that's going to be your ionic bonds. That's an incredibly strong bond, so that's going to be extremely high melting points. Becomes an anion, that's going to be your non-metal. What is the total charge of an ionic bond between the cations and anions? It is 0. The idea is that we keep going with the electron exchange until the cations plus the anions adds up to 0. In general, ionic bonds have a lower or higher melting and boiling point. It is much higher. Ionically bonded things have much higher melting and boiling points because they have lots and lots of little attractions. Which bond type is considered to be a poor conductor? That would be covalent. As a solid, liquid, or dissolved. Okay. This is true for ionics as a solid, but when they are in their liquid phase or when they are dissolved in water, ionics will conduct an electric current. Covalence will not. Which bond type is considered to be good conductors as a solid? That would be metallic bonding. Only metallic. Ionic bonds are good conductors as a liquid or when dissolved in solution, but not as a solid. Why is this true? Because of the sea of electrons. That is always the answer. When they are asking, why does a metal do blah, blah, blah? The answer is because of the sea of electrons. The metals in an ionic bond always lose electrons, while the nonmetals always gain. Metals have very few valence electrons. They have 1, 2, or 3. So it's much easier to try to lose a few than it is to gain a whole bunch. So metals are losers. Nonmetals, on the other hand, have a lot of valence electrons. They have 5, 6, 7. It's easier for them to gain 1 or 2 or 3 than it is for them to try to lose 5 or 6. Which bond type is a good conductor when dissolved in water? That would be ionic bonds. Which 2 bond types are both brittle as solids? That would be ionic compounds and covalent compounds. The only one that is not brittle is metallic because they are malleable and ductile. Which bond type occurs between nonmetals? That would be covalent. Which bond type occurs between metals and nonmetals? That would be ionic. Okay. Difference in electronegativity. So we have a little scale. The little scale looks like this. Anything below 0.3 is going to be non-polar covalent. Anything above 1.7 is going to be ionic. Everything in the middle is polar covalent. Okay? So, grab your calculators. So we have HF. So we have 4 minus 2.1. That gets us 1.9. So this is going to be ionic because it is greater than 1.7. Silicon to chlorine. Silicon is 1.8. Chlorine is 3.0. That gets us 1.2. That falls in the polar covalent range. Okay. Carbon to phosphorus. Carbon is 2.5. Phosphorus is 2.1. That's 0.4, so it's just barely in the polar range. So it's only very slightly polar. So notice how this is kind of a spectrum. If it's closer to this end, it's slightly polar. If it's closer to this end, it's significantly polar. Okay. And then it crosses over into ionic once you hit 1.7. It's kind of a a little on the side of ambiguous. So we have 2.0 minus 2.5, that's 0.5. So this is going to be slightly polar covalent. F to O, 4 to 3.5, so 0.5. So that's going to be slightly polar covalent. And then germanium to bromine, 1.8 to 2.8, that's 1. So that's pretty middle of the road polar covalent. Okay. Now they do have a crossword puzzle on the back of this. I don't feel like I need to go over it because I feel like that's going to be really redundant with most of the stuff we just went over here. So that is the review for the multiple choice part of the test. Next, we'll do the FRQ.